Hi everyone, welcome to lesson 3.6 on the second derivative test. We've seen previously how to use the first derivative test to give us information about whether or not a function is increasing or decreasing on an interval. And today we're going to see how, by making sign charts, we can use the second derivative test to learn about the function's concavity and also how the first derivative may be behaving on those same intervals. The second derivative can also give us information about points of inflection, which are going to be points where the concavity changes for the original function f of x. So let's take a minute and let's talk about concavity. Anytime you see a question about concavity, you should immediately think of the second derivative and the second derivative test. So the first derivative, that tells us about the direction of the function. Is it increasing? Is it decreasing? But the second derivative tells us about its concavity. Is it concave up? Is it concave down? Is the concavity changing? So concavity tells us how the curve is bending. What is the direction of the curve? So concave up looks like a smiley face. Concave down looks like a frowny face. Here we have an inflection point, and you can see that at the inflection point the concavity changes. In this case, it changes from concave up to concave down. Now when we used the first derivative test, we saw that where the derivative was equal to 0, that gave us a point where the direction of the function changed. It changed from increasing to decreasing, or decreasing to increasing. And we found relative extrema located at those points, either maxima or minima. And something similar happens with the second derivative. When the second derivative is equal to 0 or does not exist, we have critical points for f double prime of x. And those are values that can likely be inflection points. And those are the points where the concavity changes. So let's take a minute and see if we can relate this idea of concavity to what we already know about the first derivative and slope. So here they ask us to draw small tangent lines at points along the curves below. So I'm going to just sketch a slope graph. I'm going to draw some little slopes just to indicate how the slope is changing as we move around this graph of the function. So we can see that the slope is negative on the left side of my critical point. The critical point is where the slope is constant. In other words, it's where the first derivative, y prime, is equal to 0. We can see that on the left-hand side of my critical value, the function is decreasing. On the right-hand side, it's increasing. Likewise, let's take a look at this next graph. So here we have a point where the slope is 0. So again, that slope is constant, and f prime of x is equal to 0. And that is my critical point, C. On the left-hand side, the slopes are all positive, and the function is increasing. To the right of the critical value, the slopes are all negative, and my function is decreasing.